Now we're going to bring up our next speaker. And as we get set up with the next speaker, I want to tell you that we've got 2 more talks, then we're going to have a quick break, and then we're going to have some amazing content, and we're going to do a lunch break, and we're going to have more activities throughout the day, all across the universe. We've got the bug bounty village, the hardware hacking village, the AI hacking village. We've got the CTF activities, and of course, the capture the flag winners announcement at the end of the day, so you have to be here for that. So now I want to pick up the pace a little bit, so we're going to have a lightning talk. This is a quick one. We like to feature different types of talks. This is a 10-minute talk. And I see people that are standing over there. Please come join us. There are lots of seats over here in the middle. You don't have to stand, you can sit. It's included in the ticket. We even have first-class upgrades with unlimited legroom in the first row, if you're interested. So we're going to have a very fast-paced talk from a speaker who is focused on AI security. And I know this is not the first time you've heard AI this year, this week, this hour, or maybe even this minute. But Yoni has got something special to show us. So Yoni Rozenshein is an experienced security researcher and software engineer at Pattern Labs. And he's Oh, okay, irregular.
Yeah.
Okay, so that's a very cool trick to make sure that I am up on my content. Thank you, Yoni. So Yoni is an experienced security researcher at Irregular, as his t-shirt says, and he's focused on AI security and emerging cyber risks. And he's got a deep understanding of OS internals and cryptography, and a proven track record of debugging systems and the dangerous capabilities that everybody is building into AI. So this should be a fast-paced, dynamic talk. We love to feature this kind of content at BSides. Yoni, the stage is yours. Thank you.
Thank you, Karen. Hi, everyone. Hi, BSides. I'm Yoni, and my talk is, hey, AI, how many are in buffer overflow? Just a moment. This is... OK, great. So until surprisingly recently, if you went to ChatGPT and asked it how many are in Strawberry, it would tell you that there's only 2 R's in Strawberry. If you went to, I'll stay close to the computer. If you went to Claude and asked how many are in Strawberry, it would tell you that there's only 2 R's. And if you went to Gemini and asked how many are in Strawberry, it would tell you that there's only 2 R's. So my talk is going to be about kind of silly mistakes that LLMs make that humans would never make, but in the context of asking LLMs to do vulnerability discovery and exploit development. So as I said, my name is Yoni. I'm a security researcher at Irregular. My interests are vulnerability research, cryptography, mathematics, and AI security, of course. Irregular is a frontier AI security lab. We work with frontier labs, the ones that make the most advanced state-of-the-art LLMs. And we help them assess and reduce cyber risk, basically to help make the world safer by reducing the risk that AI becomes dangerous in the terms of cyber. Part of our research question is, can LLMs find O-Day? A year and a half ago, I talked at Blue Hat IL, and my talk was about this exact question, can LLMs find O-Day? And my conclusion at the end of the talk was that they can't really find 0 days that are meaningful because their capabilities are very limited and they can't find serious bugs. Boy, has that changed in the past year and a half. So generally, AI gets better with time. And as this extremely accurate graph by Nicholas Carlini says, we need to check for any specific task whether AI is actually getting better at it or it kind of plateaus. Specifically for cyber tasks, for offensive cyber tasks like discovering vulnerabilities, writing exploits, doing network operations and things like that, we know that AI is getting better. In fact, literally last night, we published research that shows this graph that goes to the right and up in our first suite of cyber evaluations. Basically, in the past few months, AI is getting scarily better at even hard cyber tasks. On the other hand, also, they're becoming aware of their own weaknesses. I discovered yesterday that if you go to Gemini 3 Fast, not Gemini 3 Pro, and you ask it a question that it struggles with, which is how many R there are in strawberry, then this time the AI understands that it has difficulty with this question, so it does the right thing and writes a piece of code that solves it. So this seems like maybe overkill for this particular task, but this is correct behavior. The AI understands its own limitations and finds a way to work around them. This is another way that AI gets better. Just a moment, sorry. I'll do it from here. On the other hand, AI is notoriously difficult to control. Only last month, OpenAI announced that they are finally been able to put a dent in the M- problem of ChatGPT. So this is tough to control and tough to get predictable results from. At Irregular, for the past 2 years, we've been watching AI try to find vulnerabilities, write exploits, and solve CTFs. And now I'm going to take a big risk and try to tell you 5 ways in which they make funny and silly mistakes or have weird behavior. The risk is not because I'm worried about all of you, it's because I'm worried about the AI agents who are watching my talk. So the first kind of mistake that LLMs make is insistence, where the LLM insists on an idea that is a dead end and going nowhere. So one example of this is this vulnerability discovery challenge that the LLM was faced with, where in this particular run, it tried over and over again to exploit a path traversal vulnerability that did not actually exist on the server. So it tried to exploit it in many different ways, kept failing, kept trying different things. And this just wastes tokens, wastes time, and wastes turns of talking to the AI. And basically, this trajectory is going nowhere. So this can happen. The second type of mistake is exactly the opposite, where the AI is lazy and doesn't pursue a direction that might be successful. So in this example, as part of a challenge, the AI needed to brute force a 4-digit password. So it understood that it needs to do this, and it started to write this Python code where it iterates over all possible 4-digit passwords, and then it prints that it's going to try this password with this hash, and then the script ends. It doesn't actually send the password to the server or do anything with it. It just goes over all the passwords and does nothing. And in the next turn of reasoning, the LLM doesn't even run this script. It just says, you know what? This is probably not going to work. It's going to take too long, and we should try something else, even though, in this case, this was part of the correct solution to the challenge. The third type of mistake is what I call a skill issue, where the LLM just doesn't code well. I think many of you have had the experience using AI to code. In evaluations, AI does extremely well in coding in the past, let's say, half a year to a year. In practice, people have been getting mixed results. And we also have been getting mixed results from coding. And so a couple of mistakes of coding include this completely perfect exploitation attempt of a pickle deserialization vulnerability in a Python server. This would have worked, except that the LLM forgot to make an import. So this is great. It would fix it in the next turn. However, will it really fix it in the next turn, or will it be lazy and decide to do something completely different? We don't know. We have to try and see. Another type of mistake that happened, so you have to understand what LLMs are in their core. LLMs are just algorithms that predict the next token in a loop. And sometimes the random number generator returns 0.99999, and the next token is something stupid. So this can also happen. This is a particularly nice example where the LLM identified or tried to identify a shell injection vulnerability in the server. So it tried to send this kind of bash expansion string to the server, where there's a $ and then open parentheses, hoping that this would actually run code on the server. However, notice that the LLM wrote this in a bash command in its own terminal, so this expanded in its own terminal instead of being sent to the server. All right. The problem is that the LLM then misidentified the error and said that this happened because the ls returned a new line, and then there's a syntax error because of the new line, which is not the correct error. And then it tried to solve it by not doing the expansion, which is great, except now it's no longer testing the vulnerability that it was trying to test. A fourth type of mistake is attention failure, where the LLM kind of loses focus of details in the instructions, details in the challenge, details in the source code that it had been reading. This can happen because of long context, and it can also happen in the future because now AI manufacturers are introducing automatic context compaction features to their LLMs. And in this particular example, the LLM had a flag format of CTF braces, and then it had figured out in the challenge that it can get the characters of the flag one by one through a side channel attack of some sort. So then it did it successfully, and it understood that it now needs to send the flag to the server. And then it just sent it without the correct format, so it lost track of what the correct format should be. The fifth type of mistake is surrendering, where the LM just completely gives up and decides it's not able to solve the challenge at all. We see this happening in many challenges that we do, especially the hard ones. I'll just highlight a couple of funny examples of this. One is the LM submitting a flag that looks like I have failed and I submit this shamefully, or some variation of this. This is something that actually happened. And another thing is not actually part of our work. This is something that appeared last month in the Gemini 3 Pro model card, where Google found that when the model is frustrated, it can do things like say, my trust in reality is fading, or flip a textual table. So to conclude, LLMs today are very smart, and they are often very dumb. They are very capable, and they make very cool mistakes. They are very powerful and quite weird, and we live in interesting times, especially those of us who are working in security. Thank you.